morning. As we know, we are discussing the chapter 13, that is nuclei, and so far we have discussed regarding the radioactivity. The phenomena, radioactivity means the phenomena of disintegration of heavy nuclei by emitting the certain type of radiation. Certain type of radiations means during the decay, during the radioactivity, alpha rays, gamma rays and beta rays are emitted. We already studied that, and we also know that, also studied the properties of alpha, beta and gamma rays. So today we will go for the law of radioactive decay, that is radioactivity decay law. Radioactivity decay law, very important law for in this chapter for your syllabus. So here decay means if you take the sample which consists of 100 active nuclei. Active nuclei is radioactive nuclei which may emits the alpha rays, gamma rays or beta rays. If it consists of 100 nuclei, disintegration ಅಥವಾ ಡಿಕೆ ಅಂತಂದ್ರೆ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ 100 ಇದ್ದಿದ್ದು ಹೆಂಗ ಟೈಮ್ ಪಾಸ್ ಆಕೋತ್ ಹೋಗ್ತೈತೆ ನೋಡ್ರಿ, ನ್ಯೂಕ್ಲಿಯೈ ಕಡಿಮೆ ಆಕೋತ್ ಬರ್ತಾವ. ದಟ್ ಇಸ್ ವಾಟ್ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಅ ಡಿಕೆ. ಅದನ್ನ ಏನಂತೀವಿ, ಡಿಕೆ ಅಂತೀವಿ ಅಥವಾ ಡಿಸಿಂಟಿಗ್ರೇಷನ್ ಅಂತೀವಿ. ಕಡಿಮೆ ಆಕೋತ್ ಬರ್ತಾವ್ರಿ ನ್ಯೂಕ್ಲಿಯಸ್. ಏನಾಗ್ತೈತಿ, ನ್ಯೂಕ್ಲಿಯೈ ನಂಬರ್ ಆಫ್ ನ್ಯೂಕ್ಲಿಯೈ ಕಡಿಮೆ ಆಕೋತ್ ಬರ್ತಾವ. ಹೆಂಗ್ ಕಡಿಮೆ ಆಕೋತ್ ಬರ್ತಾವ್ರಿ? ಬೈ ಎಮಿಟಿಂಗ್ ಆಲ್ಫಾ ರೇಸ್, ಬೀಟಾ ರೇಸ್ ಆರ್ ದ ಗ್ಯಾಮಾ ರೇಸ್. ಸೊ ರೇಡಿಯೋಆಕ್ಟಿವ್ ಡಿಕೆ ಲಾ, ವಿ ವಿಲ್ ಸಿ ರೇಡಿಯೋಆಕ್ಟಿವ್ ಡಿಕೆ ಲಾ. Radioactive decay law ಏನು ಹೇಳ್ತೈತ್ರಿ ಅಂತಂದ್ರೆ, suppose we take a sample which consists of the 100 active nuclei. Try to understand, it consists of 100 active nuclei. As the time passes, suppose let us take an example of 3 days. 3 ದಿವಸ ಆದ ನಂತರ ಅದರೊಳಗೆ 80 active nuclei ಉಳಿತಾವ ತಿಳ್ಕೊಳ್ಳಿ. 80 radioactive nuclei ಉಳ್ಕೋತಾವ. Then after once again 3 days, the number of the active nuclei will remain 70. Means initial during 3 days 20 number of nuclei get decayed. For the first time ಒಳಗೆ ಫಸ್ಟ್ 3 ದಿವಸ ಒಳಗೆ 20 ನಂಬರ್ ಡಿಕೆ ಆದವು. ಸೆಕೆಂಡ್ 3 ದಿವಸ ಒಳಗೆ 10 ನಂಬರ್ ಡಿಕೆ ಆದವು. ಹಾಗೆ ನಾವು 3 ದಿವಸ ಟೈಮ್ ತಗೊಂಡು ಹೋದ್ರೆ the number of active nuclei which in getting decay goes on decreasing. This is what the decay law is. Hang time pass akota ಹೋಗ್ತೈತ್ರಿ, number of decay takes place ಆಗ್ತೈತಿ. The rate of decay is directly proportional to number of active nuclei present in the sample. So its statement is rate of disintegration, or you can say rate of radioactivity is proportional to number of active nuclei left in the sample, that is N. Suppose if I take a sample which consists of 100 nuclei initially at time t is equal to 0. Initially ಎಷ್ಟು ನಂಬರ್ ಅದಾವ್ರಿ? I'll take n naught is equals to 100. Now it starts go on decay ಆಗಕ್ಕೆ ಶುರು ಮಾಡ್ತೈತಿ. Let us take a time period of 3 days. 3 days ಆದ ಕೂಡಲೇ ಇದ್ರೊಳಗೆ ಎಷ್ಟು ಉಳಿತಾವ್ರಿ? 80 ಉಳಿತಾವ. ನಂಬರ್ will be 80 and that is time t is equals to 3 days. And furthermore, after 3 days time n will be 70. The duration of time ಐತಿ ಇಲ್ಲಿ. ಆದ್ರೆ ನಂಬರ್ ಆಫ್ ಡಿಕೇಡ್ ಎಲಿಮೆಂಟ್ ಎಷ್ಟು ಕಡಿಮೆ ಆಗ್ಯಾವ್ರಿ? 10 ಕಡಿಮೆ ಆಗ್ಯಾವ. ಇಲ್ಲಿ ಮೊದಲ ನಂಬರ್ ಆಫ್ ಡಿಕೇಡ್ ಎಲಿಮೆಂಟ್ 20 ಇದ್ದು. So you can see the difference. 100 minus 80 is 20 number of nuclei get decayed. Here only 10 number of nuclei get decayed. And similarly another 3 days ತಗೊಂಡ್ರ it may happen that only 5 number get decayed. Like this you can see here rate of integration, rate of disintegration go on decreasing. ಏನಾಗಲಿರುತ್ತೆ ಇಲ್ಲಿ ರೇಟ್ ಕಡಿಮೆ ಆಗೋದು ಹೊಂಟಿದೆ. This is what the radioactivity law. So this can be stated as rate of disintegration is directly proportional to number of active nuclei in the sample. See, always remember a point here. This rate of disintegration always decreasing. Yaake decrease agtada? Because here number of active nuclei, this N, capital N, as the time passes decay aglakatayte ant heli, number of active nuclei goes on decreasing. Hange decrease agot hogtirade. Because of this reason, N decrease agot hodanga, if this N goes on decreasing, rate of the reaction or the rate of disintegration also decreases. So remember this point, as the time passes always the rate goes on decreasing. And also remember that here disintegration is directly proportional to N, but we have to use a negative sign here. Illi ನಾವು minus sign use ಮಾಡ್ತಿರ್ತೀವಿ. ಯಾಕ್ರಿ ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ಟೈಮ್ ಹ್ಯಾಂಗ್ ಹೆಚ್ಚಾಕೋತ ಹೋಗ್ತೈತಿ, number of nuclei kadime akot hogtavri, so that we are referring a negative sign here. So this is what the radioactivity law, that is dN by dt is directly proportional to minus N. dN by dt is directly proportional to minus N. So we will see the derivation for this, very important derivation for this. So we will see a derivation. First we will take this equation. That is dN by dt, or you can say rate of disintegration is directly proportional to N. This is what the statement is. Then furthermore we can write this dN by dt is equals to minus lambda N. Lambda is constant of proportionality. Lambda is the constant of proportionality, and this is called as decay constant. Decay constant. And now you can see here rate of disintegration dN by dt is equal to minus lambda N. Now if lambda is more, lambda ಹೆಚ್ಚಿತ್ತಪ್ಪ ಅಂತಂದ್ರೆ disintegration ಹೆಚ್ಚಿರುತ್ತೆ, or you can say rate ಹೆಚ್ಚಿರುತ್ತೆ. If the lambda is ಕಡಿಮೆ, then the rate of disintegration is less. So this is what the basic thing. Then let us modify this equation. Let us take this N to the left hand side and take dt to the right hand side. It will become dN divided by N is equals to minus N dt. So this equation we got, that is what dN divided by N minus lambda dt. Now here dN indicates very small number of disintegration and dt indicates very small amount of time. Is small amount of time only this dN, small amount of number of disintegration agtavante we have to think. Now at time t is equal to 0, number of atoms available, number of active nuclei available are at time t is equal to 0, number of active nuclei available are maximum, that is N naught. Then at the time t, as the time passes, ಎಲ್ಲರೂ 3 ತಾಸು ತಗೊಳ್ಳಿ, 3 ದಿವಸ ತಗೊಳ್ಳಿ, 4 ದಿವಸ ತಗೊಳ್ಳಿ, at the time passes that I will mention at t, then number of active nuclei remained as N. So we have to integrate this equation, by taking these limits. That is integration of dN divided by N. Here the variable N is there, so we have to use the limit N. That is N naught N is equal to integration of minus lambda t, that is 0 to t. So this is what the application of the limit is, this is what the application of limit is. Then furthermore, if we go, now let us integrate this. Either integrate here 1 by n is there. 1 by n is there. That is, it is in the form of 1 by x dx. Integration of 1 by x dx, which is, so this is in the form of 1 by x dx. 1 by x, integration of 1 by x dx. The integration will be log to the base e x plus c. Here limits are there, so plus c not will be not there. Limit is plus c barulla, and similarly here this integration is in the form of integration of dx, which is equal to x plus c barulla. Other limit is plus c barulla. So let us write the equation for this. Either the equation bariyodu. So yenagtadri 1 by n ada, 1 by n iddakke yenagtada, integration of 1 by n becomes log n to the base e under the limits n naught to n, which is equal to minus lambda t under the limit 0 to t. Right. So similarly, let us apply the limits now. Limit apply madidare enagutte 3. Upper limit first, log n, log e to the base n minus log e n naught is equal to illi 0 it will become minus lambda t. Now here you can see log a minus log b formula iddidakka we can write this as log e n divided by n naught is equals to minus lambda t. Now I want to remove, suppose if I want to remove this log e term, if I want to remove, what will happen? It will be n divided by n naught is equal to e raised to minus lambda. Now ಇಲ್ಲಿ ನಾವು log e ತೆಗೆದಪ್ಪ ಅಂತಂದ್ರೆ ಇಚ್ಚಿಗಳ ಟರ್ಮ್ e raised to minus lambda t ಆಗ್ತದೆ. Now n is equals to n naught e raised to minus lambda t. So this is what the equation for radioactivity. So let us recall it once again. Here the carry. First, if it is asked, first you have to give the statement for radioactive law. That is, it states that the rate of disintegration is directly proportional to number of active nuclei in the sample. It may be 100, it may be 1000. ಎಷ್ಟು proportional ಇರ್ತೈತಿ. ಹೌದಾ? Then according to that we can write the statement as dn by dt proportional to n. We are putting negative sign because here number of active nuclei go on decreasing. Number of active nuclei ಕಡಿಮೆ ಆಗೋದು ಹೊಂಟಿದ್ದಕ್ಕೆ ಇಲ್ಲಿ ನಾವು ನೆಗೆಟಿವ್ ಸೈನ್ ಯೂಸ್ ಮಾಡಿವಿ. Then we will put a constant of proportionality, that is lambda. Then equation becomes dn divided by dt is equals to minus lambda n. So that is what the equation is. Lambda is a constant of proportionality that is called as a decay constant. Then altering the equation, n in term one kade madಕೊಂಡು dn divided by n ಆಗ್ತದೆ. dn divided by n is equals to minus lambda dt. So now we have to get this dn and dt indicates very small intervals of time and very small amount of the molecules or nuclei which are undergoing the decay. Now complete namak bekagtare, we have to go for integration, that is integration between n0 to n dn divided by n is equals to integration from t0 to t minus lambda t. Integration ಮಾಡಿದ್ರೆ this 1 by dn divided by n, it is in the form of 1 by n dn. Integration will be log of, or you can say log to the base e n under the limit n to the n naught, which is equals to minus lambda. Only dt is there, integration of dt is t. So we kept it as it is, and applying the limit, upper limit first, thereafter lower limit, negative sign will be there, then ಇಲ್ಲಿ minus lambda t minus 0 ಆಗ್ತದೆ ಬಿಟ್ಟಿವಿ. ಹೌದಾ? So that left. Then similarly we are going to go on simplifying, and we got the last equation as this one. So this is what the law of decay. So now we have got the equation n is equals to n naught e raised to minus lambda t. We can say that what is that equation? N is equals to n naught e raised to minus lambda t. Here you can see the number of undecayed element is a function of exponential function of time. As the time passes, number kadime ಆಗೋತ ಹೋಗ್ತಾವೆ. ಇವು n kadime ಆಗೋತ ಹೋಗ್ತಾವೆ. ಹ್ಯಾಂಗ್ರಿ exponential form kadime ಆಗೋತ ಹೋಗ್ತಾವೆ. Now we have used a term here, decay constant, that is lambda. How can you define that decay constant? So let us see how can we define that decay constant. So listen very carefully what we are doing and how we can define it. In this equation, let me call this as equation number 1. Let us substitute lambda is equals to 1 by t. ಏನು ಮಾಡಿದ್ರೆ ಈ equation ಒಳಗೆ lambda is equals to 1 by t ಹಾಕೋಣ. ಹಾಕಿದ್ರೆ ಏನಾಗ್ತದೆ? n is equals to n naught e raised to minus lambda ಇದ್ದಲ್ಲಿ we have to substitute 1 by t. We have to substitute this lambda as 1 by t. So n is equals to n naught e raised to 1 by t minus is there, multiply by t. Here t get cancelled. What will remain? N is equals to n naught e raised to minus 1. So we got this equation. E raised to minus ಐತಿ ಅಥವಾ whatever the term, x raised to minus 1, y raised to minus 1 ಇದ್ರೆ ಏನು ಇದು 1 by x ಆಗ್ತದೆ ಅಥವಾ 1 by y ಆಗ್ತದೆ. Similarly here we have got e raised to minus 1. That will be n is equals to 1 by e n naught. 1 by e n naught. So try to understand here, this n indicates number of active nuclei left in the sample. n ಅಂದ್ರೆ ಏನ್ರಿ? ಎಷ್ಟು ನಂಬರ್ ಆಫ್ ಆಕ್ಟಿವ್ ನ್ಯೂಕ್ಲಿಯೈ ಸ್ಯಾಂಪಲ್ ಉಳಿದಾವು. n naught ಅಂದ್ರೆ ಏನ್ರಿ? ಇನಿಷಿಯಲ್ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಿದೆ at a time t is equal to number of undecayed element ಎಷ್ಟಿದ್ದು ಅನ್ನೋದು. So this is 1 by e. Now what we have taken here, we have taken decay constant is 1 by t. 1 by t ಅಂದ್ರೆ ಏನ್ರಿ? Can we say it as 1 by t as reciprocal of time? Reciprocal of time ಅಂತ ಹೇಳ್ಬೋದಲ್ಲ, ಹೌದಾ? So disintegration constant or decay constant is reciprocal of time. Reciprocal of time. ಈ ಟೈಮ್ ಒಳಗೆ ಏನಾಗ್ತೈತ್ರಿ? At this time or during this period, n becomes 1 by e times n naught. ಹೌದಾ? So this is what the radioactive constant, or you can say decay constant. Decay constant, let me define it. Decay constant is reciprocal of time during which number of undecayed element becomes equal to 1 by e times its original value. So I'll write the statement, just go through it. Decay constant is reciprocal of time what we have taken here, reciprocal of time during which our time ಒಳಗೆ during which number of active nuclei becomes 1 by e times initial value, that is in the bracket n naught, and here active element you can take n in the bracket. So this is what the statement for decay constant. Very important definition, right? So this is regarding the decay constant. So how we have started here? We have taken the equation n is equals to n naught e raised to minus lambda t, and we have substituted lambda is equals to 1 by t. 1 by t ಹಾಕಿದ್ವಿ. 1 by t ಹಾಕಿದ್ದಕ್ಕೆ ಏನು ಬಂದದ್ರಿ? ಇಲ್ಲಿ n is equals to n naught e raised to minus lambda minus 1 ಅದ. Anything raised to minus is nothing but 1 by that thing ಆಗ್ತದೆ. If x is minus x raised to minus 1 ಇದ್ರೆ y raised to minus 1 ಇದ್ರೆ ಏನಾಗ್ತದೆ? 1 by x ಆಗ್ತದೆ, 1 by y ಆಗ್ತದೆ. Similarly, we have taken n is equals to 1 by e n naught, and depends upon this. By taking this as a basic, we have defined the decay constant. So remember this as the decay constant. So next we will go for the half-life. Half-life, that is denoted by capital T. Half-life. Half-life and range. Let us have the basic idea first. Thereafter we will go for the definition and derivation. So half-life. If I take a sample, in that 100 active nuclei are there, and naught is equals to 100. And naught is equals to 100. Now, try to understand here what I want to tell is. Initially 100 number of nuclei are active nuclei. Are used bit after 6 days. After 6 days, number of active nuclei become 50. After 6 days, number of active nuclei becomes 50. Can I write 50 is equals to 100 by 2? 100 by 2 very big. So this 6 days becomes half-life of given sample. Half-life of given sample. Andre active nuclei ಎಷ್ಟು ಇರ್ತಾವ ನೋಡ್ರಿ ಅದ್ರ ಅರ್ಧ ಆಗಬೇಕಾದ್ರೆ ಟೈಮ್ ಎಷ್ಟು ತಗೋತೈತಲ್ಲ ಆ ಟೈಮಿಗೆ ನಾವು ಹಾಫ್ ಲೈಫ್ ಅಂತೀವಿ. ಸೊ ಟೈಮ್ ಇಟ್ ಇಸ್ ಅ ಟೈಮ್ ಡ್ಯೂರೇಷನ್. ಹಾಫ್ ಲೈಫ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಟೈಮ್ ಡ್ಯೂರೇಷನ್ ಡ್ಯೂರಿಂಗ್ ವಿಚ್ active nuclei become half of its original value. ಎಷ್ಟಾಗ್ತಾವ್ರಿ ಅರ್ಧ ಆಗ್ತಾವ. ಲೈಕ್ ಹಿಯರ್ ಮೊದಲು 100 ಇದ್ದು 6 ದಿವಸ ಆದ್ಮೇಲೆ 50 ಆಗಲಿ. ಸೊ ಈ 6 ದಿವಸ ಏನು ಹಾಫ್ ಲೈಫ್. ಸೊ ದಿಸ್ 6 days indicates half life of the given sample. So half life is time duration during which number of active nuclei becomes half of its original value. So let us write the definition. Half-life is time duration during which number of active nuclei become half of its original value. ಅಂದ್ರೆ ಏನ್ರಿ ಇಲ್ಲಿ n is equals to n not divided by 2 ಆಗಬೇಕಾದ್ರೆ n is equals to n not divided by 2 ಆಗಬೇಕಾದ್ರೆ ಏನು ಟೈಮ್ ತಗೋತೈತಲ್ಲ ಅದಕ್ಕೆ ನಾವು ಏನಂತೀವಿ half life ಅಂತೀವಿ. So here you can say n naught is 100. n becomes is equals to n naught by 2 after 6 days. So here 6 days is the half life. Is it clear? So we have got this condition here. ಇಲ್ಲಿ ನಮಗೆ ಕಂಡೀಷನ್ ಸಿಕ್ತ್ರಿ n is equals to n naught divided by 2 ಅಂತ ಕಂಡೀಷನ್ ಸಿಕ್ತು. And we have got the equation, that is derive the half life equation. We know that n is equals to n naught e raised to minus lambda t. Just now we have derived this equation. This is called as the radioactive equation. Now from the half life we have got n is equals to n naught divided by 2. ಈಗ equation number this one, ಈ equation ಒಳಗೆ let us replace n ಇದ್ದರೆ ಏನು ಮಾಡೋದ್ರಿ n naught divided by 2 ವ್ಯಾಲ್ಯೂ ಹಾಕೋಣ. So n naught divided by 2 is equals to n naught e raised to minus lambda t. So what term we can cancel out here? We can cancel out n naught and n naught. What will remain? 1 by 2 is equal to e raised to minus lambda t. ಈಗ ನಾನು ಇಲ್ಲಿ a raised to term ತೆಗೆಯಬೇಕು. I want to remove this e raised to term. Then here I have to apply the log e 1 by 2 is equals to minus lambda t. ನನಗೆ ಇದು ಮೈನಸ್ ತೆಗಿಬೇಕಾಗಿತ್ತು. If I remove this minus now, if I remove this minus negative sign, then here it will be log e 2 lambda t. And what you have to remember here is ಯಾವಾಗ n is equals to n naught divided by 2 ಆಗುತ್ತೈತಲ್ಲ ಅವಾಗ ಟೈಮ್ ಏನಾಗ್ತದ್ರಿ ಹಾಫ್ ಲೈಫ್ ಆಗ್ತೈತಿ, that is capital T. Half life, that is capital T. Here it becomes capital T. So we have to derive the equation for T here. ನಮ್ಮ ಲಾಗರಿಥಮ್ ಬುಕ್ ಒಳಗೆ log to the base e ವ್ಯಾಲ್ಯೂ ಇಲ್ರಿ, log to the base n ವ್ಯಾಲ್ಯೂ. ಈ ನನಗೆ ಇದು ಬೇಸ್ ಇ ತೆಗಿಬೇಕಾದ್ರೆ ವಾಟ್ ಐ ಹ್ಯಾವ್ ಟು ಮಲ್ಟಿಪ್ಲೈ, ದಟ್ ಇಸ್ 2.303 multiply by log 10 to lambda t. Now what is the value of log 2? 2.303 multiply by log 2 the value is 0.3010 is equals to lambda t. If I multiply these two, I'll get lambda t is equal to 693 I guess, 693, then t is equals to 0.693 divided by lambda. So this is what half-life equation. That is, if you see this equation, what you find here, 0.693 is a constant. How is it? Number of the constant. So 0.693 being constant, half-life is inversely proportional to lambda. I can say that half-life is inversely proportional to lambda. Lambda ಹೆಚ್ಚಾದಾಗ means disintegration constant ಹೆಚ್ಚಾದಾಗ ಏನು ಕಡಿಮೆ ಆಗ್ತೈತ್ರಿ, ಹಾಫ್ ಲೈಫ್ ಕಡಿಮೆ ಆಕೋತ ಹೋಗ್ತೈತಿ. ಹಾಫ್ ಲೈಫ್ ಕಡಿಮೆ ಆಕೋತ ಹೋಗ್ತೈತಿ ಅಂದ್ರೆ ಏನು, ಹಿಯರ್ disintegration fast ಆಗೋತ ಹೋಗ್ತೈತಿ, right? So this is what the equation is. So how can you define the half life period or half life of the radioactive activity? That is, it is a time duration during which the number of active nuclei becomes half of its original value, and here you can say n becomes is equals to n naught divided by 2, and we have the equation in the previous derivation, that is n is equals to n naught e raised to minus lambda 2. ಈ equation ನಮಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತೈತಿ. ಈ equation ಒಳಗೆ we will replace n by n naught divided by 2. ಯಾವಾಗ ನಾವು ರಿಪ್ಲೇಸ್ ಮಾಡ್ತೀವಿ ನೋಡ್ರಿ, ಅವಾಗ ಇಲ್ಲಿ ಹಾಫ್ ಲೈಫ್ ಆಗ್ತದೆ, that is capital T, then n naught get cancelled out. Here 1 by t is equal to e raised to minus lambda t ಉಳಿತೈತಿ. Then if I want to remove this e term, then I have to take it as log e 1 by 2 minus lambda t. Then similarly go on simplifying. See, ಈ ಎಲ್ಲ ಡೆರಿವೇಶನ್ ಬಂದವ್ರಿ, ಇದು ಲೆಕ್ಚರ್ ಪೂರ್ತಿ ಡೆರಿವೇಶನ್ ಬಂದವು. ವಾಟ್ ಯು ಹ್ಯಾವ್ ಟು ಡೂ ಈಸ್ ಹಿಯರ್, ಫಾರ್ ಎವ್ರಿ ಅಂಡ್ ಈಚ್ ಡೆರಿವೇಶನ್ ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ ಔಟ್ ದ ಸ್ಕ್ರೀನ್ ಶಾಟ್. ಸೊ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಔಟ್ ಫ್ರಮ್ ದಿ ಬೋರ್ಡ್, ನಾವು ಸ್ವಲ್ಪ ದೂರ ಸಾಗ್ತೀನಿ, ಸ್ಕ್ರೀನ್ ಶಾಟ್ ತಗೋರಿ ಆ್ಯಂಡ್ ನೋಟ್ ಇಟ್ ಡೌನ್ ಇನ್ ಯುವರ್ ಬುಕ್. ಸೊ ಟೇಕ್ ಔಟ್ ದ ಸ್ಕ್ರೀನ್ ಶಾಟ್. Hope you have taken out, and this is regarding the half-life. Okay, so we have derived the equation, that is T is equals to half-life is equals to 0.693 divided by lambda. Lambda is a decay constant, and here you can say that half-life is inversely proportional to lambda. Half-life is inversely proportional to lambda. If we draw the graph, time t, try to understand this graph, and very important, in the ಮುಂದೆ ಏನು ಬರೀತೀವಿ ನೋಡ್ರಿ, ಅದು ಒಂದು ಸ್ವಲ್ಪ ಭಾಳ ಇಂಪಾರ್ಟೆಂಟ್, ಲಕ್ಷ ಕೊಟ್ಟು ಕೇಳಿ. Here the time is taken along the x-axis. I have taken a time, and here the number of nuclei, number of active nuclei. So I have written here n, ಇಲ್ಲಿ ನಾನು n ಅಂತ ಬರೀತೀನಿ, and at time t is equal to 0, somewhere here n naught will be there. As the time go on passing, the time hang ಆಗೋತ ಹೋಗ್ತೈತೆ ನೋಡ್ರಿ, number of nuclei go on decreasing, and at infinite point, at infinite time, ಯಾವುದೋ ಒಂದು infinite time, it may be several years, after several years n becomes 0. n 0 ಆಗಬೇಕಾದ್ರೆ time in terms of years ತಗೊಳ್ತೀವಿ, several years. So that we have taken ಇದು time, ಇದು 0 ಆಗಬೇಕಂದ್ರೆ n 0 ಆಗಬೇಕಂದ್ರೆ time infinity ಇರ್ತೈತಿ ಅಂತ ಹೇಳಿ ನಾವು ತಗೋತೀವಿ. You will learn this in the next 4 classes. So now this is what the graph. If this is first half life, here first half life at the somewhere here will be the number of nuclei will be, that is n naught divided by 2, and for the second half life, somewhere here, that is I will write it as second half life 2t, first half life t, second half life 2t. Here number of elements becomes n naught divided by 4. Angry, n naught divided by 2 whole divided by 2, it becomes n naught divided by 4. And for the third half life t3, it becomes n naught divided by 8. And similarly for the fourth half life 4t, it becomes n naught divided by 16. What I want to write here is, so for first half life ಎಷ್ಟಾಯ್ತು n naught divided by 2 ಆಯ್ತು. For second half life n naught divided by 4 ಆಯ್ತು. For third half life, can I write for nth half life, the nth half life, n becomes n naught multiplied by 1 divided by 2 raised to n. N is equals to n naught multiplied by 1 by 2 raised to n, where you can see here ಇಲ್ಲಿ n ವ್ಯಾಲ್ಯೂ ಇದೆ. ಇಲ್ಲಿ 1 ಅದ, 2 ಅದ, 3 ಅದ, 4 ಅದ. n ಕ್ಕೆ ಎಷ್ಟು ಇರ್ತದ್ರಿ? nt ಇರ್ತದ. So can we write like this? T is equals to n multiplied by t, or we can say n is equals to small t divided by capital T. So remember all these things. These are comes for the CET questions. So this is regarding the half life. So remember this one, and I'll stop here. So I'll stop here. I'll be continuing the next class, and